Hello. Good morning. Welcome back to the lecture session on the little bit new and emerging theme, that is the Industry 4.0, having the title Smart Manufacturing and Cyber Physical Production System in the context of Industry 4.0. So, at the beginning, I would like to convey my sincere thanks, regards, and good wishes on the eve of New Year. Although it is 15th of January, still it is always desirable that better late than never. So, with this brief note, let us move on to the topic to explore the different aspects of the smart manufacturing and cyber physical manufacturing systems, which are basically two iconic representations of the state of the art cutting edge technology based, and of course inside under the vision of Industry 4.0, which is another equivalent name of fourth industrial revolutions. So before going to the details of the technical content, it is imperative to shed some lights on the background for better understanding. What is the context, and why should I go? We should go for the Industry 4.0 and the upcoming emerging or the cutting edge technologies. So let us have a quick look at the different business challenges which the present day industries are facing in the early 21st century in the global landscape. First, stringent customer specific requirements. Although I have mentioned a little bit elaborately regarding the stringent customer specific requirements, but in management fraternity, it is popularly identified by the key term mass customization and or mass personalization. So, what is mass customization? The very name suggests that customers are looking for products which are having the features which are unique to their requirements. So, each and every individual customers are looking for products which has got certain unique complex feature, and that is why I have incorporated the stringent customer specific requirements. It is a highly customized product. In the early days, in the 70s century, when the second industrial revolution came into existence, at that time the focus was the monopoly market, that is the business concept or the production concept was relying on mass production. But now this mass production concept is no longer valid. Customer or the market is highly fragmented, and every customer is highly fastidious, and they are looking for their unique feature that should be incorporated in the product. So that poses stupendous challenges on the manufacturing industries. Second, very complex and smart products with added features. In the current days product, if you take a glance toward the society or our home front, you will find a lot of products which are coming are popularly known as smart products. Smart TV, smart washing machine, smart refrigerator, likewise. Even the very handy or very popular and widely used item is the smartphone that we are using. What is smart? I will come a little bit later on. So these products are apparently looks very slim and thin, but essentially these are very highly complex. Lot of features are incorporated within the small physical space, and obviously it offers a lot of features, particularly in regard to better control and better decision making. A smartphone as compared to a conventional old type of land phone, you can find 100 times more features are incorporated, but not really. So, lot of added features should be there, and that inherently or invariably make the product highly complex. Wide varieties and different volume mix. Since the market is highly fragmented, I will come afterwards under the title of the point deep market. The market is highly divided into the different segments according to the culture, according to the financial status, according to the societal configuration. So the market is highly divided and fragmented. and that is why a particular product would be looked by only a couple of customers, potential customers. So there are, to satisfy a long population or large population, there has to be a wide varieties of the product to have a market share or a healthy market share, and definitely for each category of the particular product or the model, the amount or the volume would be rather small. So that is also difficult to deal with from the manufacturing point of view. Immaculate quality. The customers are also looking for the products which are coming in the market or upcoming are having stringent quality requirements. So at a glance, it must have a very good aesthetic feature so that it will be highly attractive from the aesthetic perspective and it catches the eyes of the customer and the neighbors, of course. Niche market, this is what I was talking about, that is the market is highly fragmented. So you cannot indoctrinate the entire population who will be interested for only one or two products. So large population divided into small segments, and each segment or even in some cases a unique customer may be looking for a particular unique product. So that is why exactly is popularly known as, or technically known as niche market. That means market is highly divided or fragmented. Now all these difficult situations or the complexities or the stringent requirements ought to be fulfilled with a lower lead time. Customer is not willing to wait for over the long time. And secondly, from the business survival or competition point of view, unless the manufacturer address these requirements and come up with a new product within the shortest possible lead time, your competitor will back the market and will lose the business opportunity. So that will indirectly or otherwise it will jeopardize the business prospect. And while doing so, apparently it may seem that we are incorporating a lot of stringent requirements, so obviously cost will be high. No, that is not possible. So it has to be a moderate or the reasonably comparable or competitive cost. Otherwise, again, customer will be switching over to your competitor. And the market, what we are talking about, or the business opportunity, that is no longer is local, it is globalized. So anyone can manufacture any item at any point of time, and it has got a global business opportunity. So threat is also from the global perspective. A lot of manufacturers we are from the what is called advanced countries or developed countries. Their manufacturers also come into the same game on the same platform of the business, thereby intensify or scaling up the competition. So these are the different challenges which the business organization or the manufacturing organization are facing in the early 21st century. Now, how to address those challenges? So to sustain or to survive in the market or in the business, the manufacturing organization should incorporate certain technologies, certain attitude, their philosophy, so that those challenges can be confronted with success. First one, intelligent and smart manufacturing, which is one of the key criteria which is enshrined within the Industry 4.0 concept. I will discuss a little bit afterwards how to distinguish between the intelligent and smart manufacturing. Both are more or less similar. Some authors or some researchers they use this intelligent and smart manufacturing interchangeably, but there is a subtle difference between the smart manufacturing and intelligent manufacturing. To be very concise, intelligent manufacturing is basically related to the third industrial revolution, when the computerization took place during 1970s to the 2010 or something like that. But afterwards, 2010 or 2011 onwards, the concept of smart manufacturing has been proliferated. There will be use of advanced automation and sensors. I have intentionally mentioned the term advanced automation. It is not that this is the first time automation is introduced into the devices or the equipment of the components. There was automation, there was sensors, but this time these are called advanced automation, advanced sensors, which rely on the principle of data-driven system. Okay, this smart manufacturing is a paradigm which is driven by data and information. So that is why it is called advanced level of automation. What are the different enabling technology under the advanced automation that I discussed? Seamless communication. Communication and network is one of the essential component or the backbone of this data-driven system to realize smart manufacturing of the cyber physical production system. So there has to be a seamless. That means without any restrictions, without any difficulties, data and information should be propagated over the computer network without any disturbances. That is one of the key requirements. Data analysis and optimization through digital twin. Basically, what exactly we require that to improve the efficiency and the productivity, or in generally the operations of the shop floor of the factory, as captured or reflected through the different key performance indicators like flexibility, adaptability, productivity, efficiency, scalability, high inventory turnover, something like this. So all these different parameters or attributes grossly capture the entire performance. That has to be revamped. Okay, so that is taken care of to the high level of or massive data analysis and of course the optimization through the digital twin. Although I have mentioned only the optimization, but apart from the optimization, there are another two different high level decision making activities like monitoring, like prediction, like simulation, in addition to the optimization. So these four different types of high level decision making are taking place in the digital twin, through the digital twin. Digital twin is one of the, I would say, the nucleus of the cyber physical production system. We will discuss afterwards. So that is the main theme of this cyber physical production system, or to realize smart manufacturing. And there should be to facilitate this data analysis and optimization, we have to rely on the widespread use of AI tools and techniques. Different types of AI tools are there according to the requirement, according to the nature of the data, according to the objectives, supervisory, unsupervisory, semi-supervisory, deep learning. Varieties of techniques are available. So those techniques we have to judiciously select and efficiently use for the different problem situation, so as to yield the better or higher level decision making. And what essentially is required, that is the introduction of or development of cyber physical production system. So in the earlier slide, just to have a recap, so these are the challenges, and to combat these challenges, the business house should equip themselves with these cutting edge technologies to confront the challenges and to stay competitive in this highly tumultuous global business world. Now, what is Industry 4.0? Now, in the backdrop of these rising complexities and disturbances, the industry is now undergoing the fourth industrial revolution, identified as Industry 4.0. This Industry 4.0, the concept was first proposed or appeared or came made to the public in the Hannover Fair. It is a basically German initiative where you find that lot of prominent automobile manufacturers all across the globe, that is the Mercedes-Benz, for example, BMW, what is called your Volkswagen, Audi. So the leading car manufacturers are from Germany. So they faced tremendous competition and challenges that how to combat or how to survive in this highly competitive global world or global market. So at that time they had thought the way the business is operated, it is not sufficient to survive or to face the competition. So keeping that in mind, to improve the efficiency, productivity and other parameters or KPIs of the plant and machinery of the factory as a whole, this I 4.0 concept was proposed and that has been propagated or disseminated all across the globe. It fundamentally relies on the digital manufacturing. So another alternative or equivalent name would be the digital manufacturing. What does it include? Industry 4.0 emphasizes on the digital manufacturing, through which adds a new dimension with the help of interconnectivity to the Internet of Things, access to real-time data and its analysis, and the use of cyber physical systems. So machinery, product, there must be possibility of the scope for installation of different IoT devices and the sensors for data acquisition. So real-time data will be acquired by the different sensors and to the IoT devices, because IoT devices are requiring some sort of microcontroller like which are responsible for some initial processing we call as a filtering and pre-processing. So that the data can be made available for transmission over the computer network to a cyber world. So the data, real-time data, maybe force sensors, maybe in the form of dynamometer, then accelerometer, temperature sensor, vibration sensors. So these sensors can be deployed into the machines and equipment suitably, which can capture real-time data, and through the IoT devices it can be transmitted or sent to the digital world. What we do have in the digital world, so we can access the real-time data to the sensors and IoT devices. In the cyber world or the digital world, there will be provision for the analysis. So a lot of powerful softwares are available, and these softwares can be accessed from the cloud, which is basically remote server. So cloud is a different concept and it has got a relevance to the industry 4.0 and is considered as one of the enabling technology. So through the cloud, different softwares like say MATLAB, maybe Python, Anaconda, Jupyter, and lots of others are there. So according to the requirement, according to the use, according to the unique area, one can select or access any typical software which can be utilized for the analysis purpose. And when this analysis is carried out and we come to a higher level decision making, those output or the your outcome of the decision making can be considered as an actionable conclusions. What does it mean by actionable conclusions? That means each outcome can be once again sent back to the software level to tune the process parameters so that we can improve the productivity, we can improve the efficiency, or there may be some other advanced function like in the current days which is very becoming popular, that is called prognostic health monitoring. We can predict the health of different critical equipment from the, and thereby we can save a lot of time, thereby preventing the system from the premature failure in the system, in the physical system, that is in the shop floor. So this Industry 4.0 is basically data driven of the digital technology, where there is a possibility of integration between the physical world and the cyber world or the digital world. Okay. So there, in this particular diagram I have shown, I have incorporated, or it is standard 9 pillars of Industry 4.0. You see, additive manufacturing. What it is? Additive manufacturing is a emerging area of manufacturing where directly from the raw powder or from your liquid polymer, shape generation is possible for highly customized or personalized product. Augmented reality. This is a very powerful approach to have your interactive session or interactive approach in a computer platform to better visualize or to have a better effect about the physical object or physical operations in a interactive mode through the lot of sensory effect like sound, like light, like noise, something like this. So augmented reality enhances the perception about the real life scenario, real life situation or the real life world in a computer platform. Big data, you know that it is for the data analytics. Lot of statistical tools and other techniques are possible to apply under the purview of big data. Now the question is why it is called big data. This big is captured by the 3 different parameters. The enormous volume, it is called 3V. Enormous volume, that is large volume of data, large varieties of data, and large velocity of data. That means data are flowing through the network very fast with high velocity, wide varieties of data, and of course high volume. So these 3 V's are responsible to capture by the term big data. Autonomous robot. Robot is nothing new. In 1970s onward, there was industrial robot which are the part of automation. But here you see the difference in the term autonomous. When we define we consider a particular device or equipment as an autonomous tag, it must have to have certain features. One is sensing, connectivity or connectedness over the network, and some sorts of computing and eventually decision making attributes. So when these attributes are available in a or features are available in a particular equipment or device, we can give the tag autonomous. Simulation. This is what exactly the real life situation, the behavior of your car or any other product. We can simulate in a computer platform in a better way. So this simulation is carried out in the digital twin along with some other improved version or improved activities like optimization, monitoring, prediction. Internet of Things I already talked about, and since everything is carried out, or the data information propagation takes place over a computer network, so there is every possibility of cyber attack or cyber disaster. So there must be sufficient and appropriate security aspect to protect the system from any unwanted attack by the intruders. So Industry 4.0 offers a very comprehensive, interlinked and holistic approach to manufacturing. It offers a holistic approach. That is, all activities under the manufacturing should be data driven or the data centered, and they should be highly or tightly integrated to the computer network. It connects physical world with the digital world and allows for better collaboration and access across departments, partners, product and people. So what I had already mentioned, that it connects this is the key requirement of the cyber physical production system. That is connectivity or establishing connection between the physical world with the digital world and allows for better collaboration across all the stakeholders. It is not only the connection between the physical shop floor and the corresponding digital world. Some other stakeholders like partners, like vendors, like customers, all can be having the same network through which it is possible to communicate and connect or send the data and information. Industry 4.0 focuses on better control process operation by leveraging instant data. So that is the key concept, that all the decisions will be taken care of based on the instant data or the real-time data. That is the key requirement to enhance productivity, improve processes, and eventually to register or boost the growth. So industry from the technological perspective, it hinges on advanced automation and sensors, as I had mentioned earlier. Computing such as Internet of Things, cloud computing, data analytics, machine learning, AI, and seamlessly establishes interconnectivity among the facilities through a communication network. So if you scan from the top to this, at the end of this particular point, advanced automation and sensors for the IoT devices for real-time data capturing, then connection for data transfer from the shop floor of the device to the cyber world. In the cyber world, there will be possibility of the provision for data analysis, machine learning, AI for higher level decision making by accessing the different softwares from the cloud, which is popularly known as cloud computing. So it eventually creates a complete network of different entities. The vision of Industry 4.0 is realized through the smart factory or smart manufacturing and the cyber physical production systems. That means, if you go to the title of this particular presentation, I have mentioned smart manufacturing and cyber physical production system in the context of Industry 4.0. So this smart factory or the smart manufacturing and cyber physical production system are the two iconic representations of the Industry 4.0 paradigm. Now both are not dissimilar, both are same. Only thing, the perspective or viewing is different. When you talk about the smart factory, the smart manufacturing, all the activities of the particular organization should be driven by the data, and it must have a smart component. So to define a component as a smart or activity as a smart, three requirements are there: sensing, connectedness, computation, and control of the decision making. So from the data perspective, so all the activities or all the equipment or the devices or the products should manifest the smartness adequately. And from the physical configuration point of view or the integration point of view, in one side we have got a physical shop floor comprising machines where processes can be carried out. There may be product which comprises the physical systems, and on the other hand we have got the digital world or the cyber world, and through the communication, data and information propagation takes place. So that is the another viewpoint of cyber physical. So it is a combination of one has got a cyber part and another has a physical part. What I have given you as a note, the cloud computing has become so advanced, it has given rise to the concept of cloud manufacturing, particularly to realize manufacturing with a different viewpoint. In generically or traditionally, manufacturing is considered as a production oriented, but under this paradigm, the cloud manufacturing, it is service oriented. So whatever facilities a particular organization do have, whether design, experimentation, testing, everything, product development, everything should be considered as a service. In another different PPT, I will discuss all about how to realize cloud manufacturing by using the or based on the concept of cloud computing. As defined by NIST, National Institute for Standards and Technologies, they have defined smart manufacturing is a fully integrated collaborative manufacturing system that responds in real time to meet changing demands and conditions in the factory, in the supply network and in customer needs. So customer, vendor, supplier, different departments of the manufacturing needs all under the single network. So all the stakeholders are present under the purview of this smart factory. SM is a data intensive application. What I had emphasized that it is a data driven paradigm or data intensive paradigm. So data intensive application of information technology at the software level and above to enable intelligent, efficient and responsive operations. Obviously it is intelligent, or we should say in the current world that is a smart system. It must reach the adequate or higher level of efficiency, and at the same time, which is extremely important, that is responsive operation. Based on the decision making take place in the digital world through the digital twin, quickly we can rectify or regulate the process so as to improve the productivity or efficiency or other parameters or the KPIs. That is why this responsiveness is one of the key attributes of smart manufacturing. So smart factories therefore have a smart design, smart manufacturing, smart scheduling. As I told earlier, whatever may be our activities, it must have a smart tag, or it should be accompanied by smart features, so as to cover entire range of activities under its purview, and at the same time, each activity is characterized by data collection, data analysis, which will be eventually used for smart decision making. So to start with, we collect the data by sensors and the IoT devices, communicate over the network through any type of network. The higher level decision making is being taken place in the digital world by AI, ML techniques or the data analytic techniques by accessing the different software from the cloud, and the result of the analysis will be utilized for regulate the process in a better manner. So that is what exactly the smart decision making. So whereas traditional intelligent manufacturing is based on mechatronic system, smart manufacturing is data driven. In the beginning, I told on the first or second slide, the intelligent and smart manufacturing. So the term intelligent manufacturing, which was coined with basically the computerized automation, that is the PLC, where there is an intensive use of microcontroller, PLCs, microprocessor, that is the CNC machine, robotic system, FMS, automated guided vehicles. So those are basically programmable, and that is how. And that is why those are given the name intelligent manufacturing. So according to the program, we can get the work done by those non-living systems without human intervention. But what is prominent to distinguish the smart manufacturing from the traditional intelligent one. Here it is data driven and of course in real time. So these certain differences exist within the earlier intelligent manufacturing and the present days or the present generation smart manufacturing, which is exclusively real time data driven. So this is a scheme of cyber physical production system. So it is basically, as I told, integration of physical manufacturing equipment and sensors with the virtual world through internet coupled with big data analytics, AI and cloud computing, so as to convert the existing manufacturing system to a more powerful and smart through enhanced decision making, computing and communication. So in this particular picture I have taken from the tower, it is a very good work, very prestigious research article, having very large number of citations. You see that the entire figure is divided into the two halves. One is lower part, which is basically which represents the shop floor of the physical part, and the upper one, which is enclosed in the rectangle, that is the cyber of the digital part. So what we do have, it is symbolically presented with a robot. So different type of sensor that can be installed at suitable locations, so that different parameters or the different attributes, operating variables can be monitored. Okay, and of course from the different joints, different drive systems, and those data can be sent to the cyber world or the digital world through a data communication system. Once the data is made available, it requires lots of your pre-requirement or pre-activities in the form of your data filtering, data pre-processing, data organizing, data saving, data storage, data investigation, something like that. So generically those are the things called data management. And while sending the data from the shop floor to the cyber world from a varieties of devices, the interoperability requirements have to be satisfied. So interoperability is a characteristic of the IT system or the communication system, which enable your barrier-free communication from the varieties of sources, so that data can be sent for the future analysis purpose. And of course, the semantic ontology aspect, these are the part of IT activities. So those activities ought to be fulfilled before to make it amenable for data analysis. What I was talking about, so the different softwares can be accessed from the cloud by the decision maker. So once different analysis, this is a symbolic analysis is given. So once the higher level decision making is carried out, eventually we ought to regulate or control the physical device or the physical equipment which is installed or lying in the shop floor. So that is how the loop is being closed. So physical world, data to the cyber world, after decision making, finally control is taken care of by the propagating suitable or regulating information back to the physical world once again, thereby closing the loop. So CPPS provides a new paradigm of manufacturing by establishing communication and cooperation among equipment and devices and information system in a decentralized manner and in real time to derive enhanced benefits in the wake of rising business challenges. It is characterized by smartness, that is the autonomous, connectedness and responsiveness, and manifest self-X capability, that is the self-awareness, self-prediction and self-optimize. I will illustrate. The cyber physical system this smart manufacturing, it is characterized by the three main properties. Smartness, that is the autonomous, in respect to that 9 technological enabling technology of industry 4.0, the 9 pillars. There I have mentioned autonomous robot. So autonomous and smart both are interchangeable or equivalent. So smartness has to be there. That means intelligence, computing, communication and decision making aspects will be manifested or demonstrated. Connectedness, and this connection between the devices of the physical world and the cyber world, that is taken care of by the internet communication. And finally, responsiveness. How best and how quickly we can adjust or regulate the process so that we can improve the performance of the physical system of the physical devices. And when we can do so, the system is poised to develop certain qualities which generically called self-X capabilities. What is self-X? Anything can happen, any higher level activities like self-awareness. Self-awareness means the system from its own will be able to diagnose what are the critical conditions or the health condition of the critical components which is susceptible to failure in the near future. What is their performance level? So those are the parameters of those are the features which can be captured by the self-awareness. Self-prediction, same thing. Self-optimize or self-regulate. So whenever the system without any external assistance can carry out any type of activities from its own, those are generically identified for the self-X. Anything you can add over here depending on the complexity and the power and the nature of the activities. Self-organizing, when several such systems organize amongst themselves without any external intervention of the human being, how to configure their activities, how to reschedule their activities in the wake of any disturbances or in the exigencies, that is called self-organizing capability. So their self-organizing capability actually is a part of the agent-based system that it has been carried forward in the cyber physical production system as well. And agent-based system is a very potential approach to control, software control of the your manufacturing education system control, and that can be very successfully and efficiently realized in the light of cyber physical production systems. This is also very popular to depict the hierarchy of different activities which are captured by the 5C. This work credited to Lee et al. In their paper 2015. So first to start with smart connection level. So in the software level, to the sensors and the IoT devices can be connected to the different component to monitor or to gather information about the processes. For our metal cutting point of view, you can say the prominent use of sensors like your dynamometer for force measurement, temperature sensors, some RFID can be installed successfully, accelerometer for vibration monitoring, power meter for power measurement, velocity tachometer. So all different process variables we ought to gather. So that is what exactly is the smart connection level. These are the why it is called plug and play. Very easily there will be provision for ease of installation and commissioning or fitting of those sensors. Once data is collected, then the next higher level of activities is data to information conversion level. Data to information conversion level means multi-dimensional data correlation and degradation and performance prediction. With a large volume of data, we cannot come to a conclusion. So unless and until we convert this data to useful information, so that we can have an actionable conclusion, then and then we can say that we can come to some logical decision which will lead to some concluding actions, so that we can better regulate the process and thereby improve the efficiency and the performance. So data to information conversion level is the second hierarchy. Third level, cyber level, twin model. This is what exactly is called digital twin. So this, after converting, it is now made available in the cyber world for higher level decision making in the digital twin. So clustering for similarly data mining, as I was talking about, in the part of data management, this data mining is a very crucial activity. Fourth level, integrated simulation and synthesis, remote visualization for regional, collaborative diagnostics and decision making. So in the digital twin, maybe in the next slide we will be able to discuss in detail about the digital twin. So we will have the cyber level in the digital twin model. That means in the cyber world, we can have a digital replica of the physical system available in the software, where we can carry out all sorts of higher level decision making activities like prediction. So in the third level, it is the cyber level, where data from the physical world has already been sent over the network to the digital domain of the digital world or the cyber world for carrying out higher level decision making. So in the final, for the fourth level, that is a bit higher, cognition level, where integrated simulation, synthesis, collaborative diagnostic and other different types of decision making in the form of simulation, prediction, monitoring and of course the optimization, all are being carried out for the final regulation of the process in the shop floor. So that is why it is called cognition level. That means cognition is basically derived from a human part, where human mind and brain is utilized to facilitate decision making. So the same aspect or the same feature is now being taken care of by a non-living system through the data and information. So in the fourth level, we do have the cognition level, where we can add different capabilities of the feature, as we had discussed in the earlier slide, that is the self-X capability. So those self-X capabilities in different orders can be developed to call self-configure for resilience, self-adjust for variation, self-optimize for disturbances. So different feature including self-organization. When several machines interact with there to solve certain problem in a holistic manner, in that case we can incorporate or the system can develop another attribute under the same broad title self-X, that is self-organizing. So self-awareness, self-prediction, self-monitoring, self-optimize, all generically can be titled under self-X capability. So this is how the 5C architecture very successfully and efficiently captures the different levels of activities showing that particular hierarchy. So that's all about this basic concept of the Industry 4.0 vision and two iconic representation of under Industry 4.0, that is smart factory or the smart manufacturing and the cyber physical production system. Both are same, only the viewpoint is different. So essentially we are now living in the age of smart device, smart equipment, smart activities which are enabled through the data intensive different technology leading to the digital manufacturing of the digital world. So thank you for your patience hearing. I believe that you have got an initial idea, and afterwards according to your choice, according to your interest, you can explore the different activities under this the vision of Industry 4.0 or smart manufacturing, cyber physical production system, and of course the digital twin, that is the one of the key component which I call as the nucleus of this cyber physical production system, which we discuss in our next presentation as soon as possible. So thank you very much once again for your patience hearing.